Dust is almost an insult. It is the word we use for what gathers in corners, what settles on shelves, what turns light dull and makes a room feel neglected. It suggests something minor, disposable, irritating. So when people hear the phrase interstellar dust, the mind usually makes the same mistake twice. It imagines something thin, passive, and unimportant. A faint cosmic grime suspended between the stars. James Webb has forced that picture to collapse. What it revealed was not simply more dust, or prettier dust, or sharper dust. It revealed that what we'd been calling dust was, in many places, a hidden architecture of the universe itself, layered, chemical, dynamic, shaped by shock waves and starlight and cold so deep it almost escapes intuition. By the time we're done, that ordinary little word is going to feel too small for what it contains. If you enjoy slow, serious journeys into realities that become stranger the closer we look, staying with this channel helps more than you might think. And if that sounds like your kind of night, you're in exactly the right place. So let's begin somewhere familiar. Imagine a dark room in an old house, and a thin beam of sunlight crossing it from a window that has not been cleaned in a while. You do not usually notice the air itself. Then the light strikes at the right angle, and suddenly the room is crowded with particles. They drift and tumble in silence. For a moment, the invisible becomes visible only because light has hit it just right. That image helps, and then it misleads us. Because the dust between stars is not floating through some calm, empty room. It exists inside an environment of radiation, magnetic fields, collapsing clouds, stellar winds, shock fronts, and temperatures that range from furnace-hot to almost unthinkably cold. It is part of an active medium spread across light years, sometimes gathered into dense lanes, sometimes stretched into filaments, sometimes blasted outward, sometimes incorporated into the raw material of future worlds. It is less like dust in a still room than weather in an ocean you cannot see with human eyes. That matters because for a very long time, the universe looked simpler than it really was. Not empty, not exactly, but smoother, hazy in places, smudged around the edges. Astronomers knew dust was there and knew it mattered. It blocked visible light, reddened what passed through it, re-radiated energy at longer wavelengths, and complicated the view. It was a known presence, but known is not the same as understood, and seen is not the same as read. That is the real shift Webb brought with it. It is easy to talk about it as a more powerful telescope, and in one sense that is true. But the deeper truth is that it changed the kind of access we have. It does not simply magnify what our eyes would see. It works in infrared, in parts of the spectrum where cold material glows, where hidden structure emerges, where dust stops being only an obstruction and starts becoming evidence. That is a profound reversal. Because when an ordinary observer hears that a telescope can see through dust, it sounds as if dust is the thing being overcome on the way to the real subject. Stars behind it, galaxies behind it, some more important destination. But Webb has made something else unmistakable. In many cases, dust was never just the curtain. It was part of the stage, part of the machinery, part of the story itself. You can feel this most clearly in the way some of Webb's images change the emotional texture of known objects. Regions that once looked like rough clouds or faint obscuring bands suddenly revealed internal layering. Not random blur, but structure. Fine structure. Boundaries and ripples and nested fronts. In some remnants of stellar death. The dust appears almost carved, like grain in old wood or tide lines cut into a shore by repeated motions over time. You are no longer looking at a stain across space. You are looking at a record of events. And once you see dust that way, an unsettling thought arrives. If this material has form, then that form had to come from somewhere. If it has layers, something produced the layers. If it is filamentary, something stretched it, compressed it, or sculpted it. If it glows differently from one place to the next, then one region has a different history from another. A cloud stops being a cloud in the casual sense. It becomes terrain. That is one of the quietest and most important changes in modern astronomy. Whole regions of space have moved, in our minds, from backdrop to landscape. When Webb looked into the remains of exploded stars and into dense regions of the interstellar medium, what emerged was not only beauty, it was legibility. The dust and gas were not spread in a smooth wash. They were folded and layered and knotted. In some places, the appearance suggests multiple sheets lying across one another along our line of sight. The way distant mountain ridges can seem like one shape until morning light separates them. In others, it suggests turbulence and shocks, pressure fronts moving through matter, collisions that leave texture behind. Space is not still. Even that sentence is not strong enough. Space between stars is often treated as a kind of blank interval, a waiting room between more important things. But the interstellar medium is an environment with memory. It gets stirred, heated, cooled, compressed, ionized, enriched, and reorganized. Stars are born from it and then later attack it with light and winds. Some of them die violently and send fresh material back into it. Dust is inside that circulation the whole time, which means the word medium is better than the word emptiness, and the word process is better than the word dust. Because the moment we stop treating these grains as static specks, a much larger reality opens. A grain of interstellar dust is tiny, yes, often smaller than anything a person could ever feel between their fingers. But smallness is not the same as triviality. A seed is small, a cell is small, a transistor is small. Entire systems can depend on units too tiny to attract the eye. Interstellar dust belongs in that category. These grains are made from heavy elements forged in stars: carbon, silicon, oxygen, magnesium, iron, and more, assembled into solids with different sizes, different structures, different optical behaviors, different strengths. Some are silicate-rich, some are carbon-rich. Some may carry icy coatings in cold environments. Some are altered by radiation. Some are shattered in shocks. Some grow. Some erode. Some survive conditions that destroy others. So even before we get to the chemistry, the first illusion has already fallen away. There is no single thing called dust out there, any more than there is a single thing called rock on Earth, pebble, ash, glass shard, salt crystal, soot, sand grain, frost. We use one word for convenience, but the reality is a family of materials with different properties and different histories. Webb has not invented that idea. What it has done is make the consequences of that idea much harder to ignore. A smooth haze can hide simplicity or complexity. A textured medium cannot. Texture is a confession. And once dust begins to confess its structure, it becomes impossible not to ask what else it has been doing in the dark all this time. Because if these grains are truly embedded in the life cycle of stars and clouds, then they are not merely drifting through space, they are participating in what space becomes. Not metaphorically, physically. They absorb light, they re-radiate energy, they help regulate temperature, they change how gas cools, they influence what collapses, what survives, what forms, they alter what can be seen, and just as importantly, what can happen. That is where the story begins to deepen, because dust does not only shape the view, in the coldest places, it helps shape the chemistry. And that is where these quiet grains stop looking like debris and start looking like workbenches, scattered through darkness, waiting long enough for the universe to begin building on their surfaces. If that sounds almost too intimate for deep space, that is partly because our daily instincts are built for warm, crowded environments, not for chemistry unfolding on tiny frozen solids in near darkness over spans of time that make a human century look like a passing weather front. A cloud between stars can be brutally cold, not vaguely cold, cold enough that ordinary intuition begins to fail. In those regions, free-floating gas particles do not move with the frantic speed they would have in a hot environment. Certain atoms and simple molecules can stick to dust grains and remain there. Layer by layer, a grain can gather a thin icy mantle. Not the kind of ice that crunches under a boot, not even the kind that fogs a window, but microscopic coatings built atom by atom in silence. On those surfaces, reactions can occur that would be far less likely in open gas. So the image to hold is not debris drifting uselessly through nothing. It is countless tiny solids, suspended in the dark, wearing coats of frozen material, hosting encounters, storing ingredients, and changing what kinds of molecules can emerge. It is difficult to make that feel real because the scale is so small and the environment so alien. But sometimes the most decisive work in the universe happens where nothing seems to be happening at all. This is one reason dust matters so much to star formation and, eventually, planet formation. Dust helps clouds cool. Cooling matters because hot gas resists collapse. If a cloud can shed energy, parts of it can contract more effectively under gravity. Those dense regions can become the birthplaces of stars. Later, around young stars, dust grains in disks collide, stick, fragment, and grow through long, uneven processes that eventually help produce larger bodies. The story is complicated and never perfectly tidy, but the broad truth is simple enough to feel. Without dust, the universe we know would not assemble in the same way, and that means something almost absurdly direct. Some of the material conditions that make rocky worlds possible begin with grains so small that calling them grains already feels generous. It also means that dust carries a dual identity that our language struggles to hold. It is both leftover and precursor. It is the aftermath of one generation of stars and part of the opening condition for the next. It is waste only if you ignore time. Given enough time, waste becomes infrastructure. Webb has sharpened that truth because it can do more than detect vague emission. It can separate environments, isolate signatures, and reveal that not all dust behaves alike. This is especially striking in regions where intense radiation from nearby stars is chewing into surrounding material. If dust was simple, we might expect a relatively uniform response. Instead, Webb has shown landscapes of variation, where one zone preserves certain carbon-bearing features and another suppresses them, where chemistry changes over remarkably short distances, where the edge of a cloud becomes less like a border on a map and more like a living gradient. A good place to feel that is at the boundary of a harsh stellar environment, where ultraviolet light floods into neighbouring material. At such boundaries, matter is being sorted by exposure. Some structures survive deeper in, some are altered near the surface, some are stripped away. Webb's view of these regions has made that sorting visible with unusual richness. Aromatic carbon-bearing features, often associated with PAHs, do not appear as a single smooth glow. They vary. Their strength and character change from one patch to another. Chemistry becomes geography. That phrase is worth staying with for a moment. Chemistry becomes geography. We are used to thinking of geography in terms of mountains, coastlines, valleys, deserts, large things, continuous things, places your body could enter. But in the interstellar medium, geography can mean changes in radiation field, density, grain size distribution, ionization, and molecular survival over distances that are huge by human standards and still tiny by astronomical ones. Webb has made some of that differentiation visible enough that you can no longer honestly picture a cloud edge as a single uniform surface. It is more like a contested shoreline, with structures and transitions all the way through it. That alone would justify the title's promise. Dust is more complex than most people ever imagined. Yet the story keeps widening, because complexity here does not only mean internal variety, it also means selective survival. When stars blast nearby regions with intense light, or when shocks move through material, some grains and molecular carriers are damaged or destroyed. Others persist longer. Some may reform. Some may be replenished. In calmer descriptions of the cosmos, we often imagine matter simply being there, present, occupying space. But the truth is more ecological than that. Environments favour some forms over others. Conditions filter matter. Radiation is not just illumination. It is pressure and damage and sorting. This gives the interstellar medium a kind of harsh tenderness. Harsh because so much of it is being broken, eroded, or altered. Tender because these transformations are not random noise. They determine what future states become possible, which compounds can survive, which grains can carry icy mantles, which regions remain chemically fertile, which material joins the next cycle of collapse and starbirth. If you are somehow able to drift through one of these boundaries, no human body could survive it. But the larger impression might not be one of dramatic violence. It might be one of gradients. One area glowing differently from the next. One layer thinning, another brightening, another holding on. That is part of what makes Webb's contribution so profound. It has not merely shown us more objects. It has shown us that the spaces between objects are full of transitions. And transitions are where stories happen. That becomes even clearer when we move from cloud edges into more explosive settings. because the question naturally sharpens. If dust is so important, and if some environments destroy it, then where does the supply come from? How is the universe continuously repopulating itself with these grains? For a long time, astronomers suspected several major sources. Aging stars can shed material. Stellar winds can create conditions for dust formation. Supernovae, the violent deaths of massive stars, have long been candidates as major dust factories, especially in the young universe. But turning suspicion into confident evidence is difficult. It is one thing to know that heavy elements are made in stars and explosions. It is another to show how much of that material condenses into dust. What kind of dust forms, how long it survives the surrounding shock environment, and whether enough of it can persist to explain the dusty galaxies we see very early in cosmic history. This is where the story grows more dramatic without needing to exaggerate. Because a supernova is not a gentle place to build delicate solids. It is an extreme event, an expanding aftermath of violence, heat, collision, and shock. To imagine dust forming there sounds almost contradictory, like imagining frost assembling inside the memory of a fire, and yet that is close to what the evidence now suggests in some cases. Webb has identified substantial reservoirs of dust in supernova remnants, strengthening the case that these stellar deaths do not merely scatter raw elements, they can manufacture and hold significant quantities of actual dust. That matters for two reasons at once. It tells us something local about the life cycle of matter after a star dies, and it tells us something cosmic about how the early universe got dusty so quickly. Because when we look far enough away, we are looking back in time. Some of the galaxies Webb has observed existed in the universe's first billion years, startlingly early in the larger story, and some of them already show dust that appears surprisingly mature or abundant. That demands an explanation. Long, leisurely cycles of grain growth and reprocessing may not always have had enough time, so rapid sources become critically important. Suddenly, those remnants of stellar death are no longer side stories, they are supply lines. And the image changes again. A supernova remnant is often imagined as a monument to destruction, a final wound expanding into space. But if it is also a dust reservoir, then the wound is manufacturing future conditions. The debris of demolition becomes raw material for new architecture. Elements forged in a star's interior, hurled outward in catastrophe, begin condensing into grains that may later help cool clouds, alter chemistry, and contribute to the ingredients of planets, not immediately, not cleanly. Not without losses, but the cycle is real. Death here is not the opposite of construction. It is one of its phases. Once that sinks in, you start to feel why the title had to be about complexity rather than mere discovery. Because every new observation is not just adding a fact, it is exposing overlap. Dust is texture and chemistry, obstacle and evidence, fragility and persistence, aftermath and beginning. And that overlap becomes even stranger when we leave the remnants of explosions and follow dust into places where it forms not from a single death, but from repeated stellar confrontation. There are stars so unstable, so powerful, and so stripped down by their own intensity that they seem almost hostile to the idea of making anything delicate. Their winds race outward at enormous speeds. Their radiation is ferocious. The environment around them is not the sort of place a quiet mind would choose for the assembly of fine solid grains. And yet even there, under the right conditions, dust can appear. That is one of the recurring lessons of this subject. The universe is not interested in our sense of what should count as a proper workshop. It builds where it can. In systems like Wolf-Rayet 140, Webb has been able to follow carbon-rich dust shells formed where stellar winds collide. This is a deeply beautiful correction to the old intuition. Dust is not only found in old, settled regions or in the long-cooled remains of ancient events. It can be produced in an environment of ongoing conflict, where two powerful stars repeatedly drive matter into one another, compressing gas into conditions where new grains can condense and drift outward in expanding shells. The visual result is astonishingly orderly, ring after ring, like arcs spreading across water after a stone impact. Except these are not ripples in a pond. They are shells of carbon-rich material cast into space over repeated cycles. The comparison that comes closest may be tree rings, except instead of being buried in wood, they are written into the dark around stars. Time is becoming visible through dust. That point matters more than it first seems to, because once dust appears in repeated shells around a system like that, the material is no longer just evidence of a process. It becomes a clock of a kind, a record, a sequence of moments preserved in structure. One shell marks one episode, another marks the next. Distance becomes elapsed time, pattern becomes memory, dust keeps score. That is a very different emotional experience from the old image of cosmic dust as faint clutter. It means matter between stars can preserve rhythm, not just chemistry, not just composition, rhythm. And when you place that beside supernova remnants, another layer of complexity comes into view. Dust is not made in one way. It does not come from a single source, under one standard set of conditions, with one predictable grain profile and one fixed fate. Some dust is forged in the aftermath of stellar explosions. Some condenses in the colliding winds of massive stars. Some is altered in harsh radiation fields. Some picks up icy mantles in deep cold. Some is shattered. Some grows. Some gets swept into galactic outflows. Some survives long enough to become part of future clouds and disks and planets. That plurality is exactly what Webb has helped make emotionally legible. Older models and older observations already pointed in this direction. But when an instrument can resolve more detail and separate more signatures, the complexity stops feeling like a technical footnote and starts feeling like the truth of the medium itself. Interstellar dust is not one substance moving through one life cycle. It is a population of materials, in many states, crossing many environments, each with its own pressures and timescales. Which means every patch of dust we see is, in some sense, a mixture of biographies. Some grains may be comparatively fresh, condensed from recent ejecta before much weathering has occurred. Some may have spent long ages in the interstellar medium, reworked by radiation and collisions. Some may carry coatings acquired in cold clouds. Some may be fragments of larger grains broken apart in shocks. Even in one region, what looks like a visual unity can hide a crowded history of different origins and different futures. That becomes especially important when we widen from local environments to whole galaxies, because galaxies are not still containers for matter. They churn, they form stars, lose gas, drive winds, absorb mergers, enrich themselves unevenly, and reshape the balance between dust creation and dust destruction over time. Once again, the old mistake is to imagine dust as a static ingredient sprinkled through a galaxy like flour through dough. In reality, galaxies sort, move, and transform dust continuously. Webb gave one of the clearest reminders of this in observations of the starburst galaxy M82. This is not a quiet system. It is undergoing intense star formation, and that activity helps drive material out from the galactic disk in a vast wind. When Webb traced emission associated with carbon-bearing particles and small grain-like carriers in those outflows, it made a powerful point visible. Dust-related material is not confined to calm nurseries tucked inside sheltered clouds. It can be caught up in galactic scale movement, lifted and transported in environments energized by stellar feedback. Think about what that means in human terms. We tend to imagine a galaxy as something serenely posed in deep space, like a photograph on a wall. Even when we know better intellectually, our emotions often lag behind. But a galaxy like M82 is not posing, it is venting. Material is being pushed out along enormous structures, carrying with it part of the record of star formation and part of the raw matter from which future structures could emerge elsewhere. Dust is inside that motion. Dust is not just what a galaxy contains. Dust is part of what a galaxy does. That reframe is enormous. It means that when we speak of interstellar dust, we're not always speaking only of the space between individual stars inside one quiet cloud. We're also speaking of a medium that participates in circulation on the scale of galaxies. Tiny grains become actors in very large flows, and because dust changes how light travels, and because its properties affect how we interpret distant systems, understanding that circulation is not merely a side concern, it changes how we read the universe. In some sense, dust is both local and cosmic at once. It matters in cold, dark pockets where chemistry accumulates on a single grain, and it matters in galactic winds stretching for thousands of light years. It matters when a cloud begins to cool toward collapse, and it matters when we try to understand why a distant young galaxy looks the way it does. This is another reason the title's promise has to be paid carefully. the complexity Webb revealed is not decorative intricacy. It is consequence across scale. Small grain, large consequence. That pattern shows up again when we look deep into cosmic time, because one of the quiet shocks of the Webb era has been how rapidly the early universe seems to have acquired ingredients that, in simpler stories, feel as though they should take longer to develop. Not everything observed early is fully understood. Some cases remain debated. But enough has emerged to make one thing unavoidable. Dust arrived early, and in some galaxies it seems to have arrived in forms that are difficult to explain with slow, leisurely processing alone. This is where the emotional texture changes once more. The early universe is often imagined as raw, unfinished, almost clean in comparison with the later cosmos. There is truth in that. Heavy elements had to be forged by stars because the Big Bang did not make the whole periodic table. Structure had to grow, galaxies had to assemble, time had to do its work. But Webb has repeatedly shown that time in the young universe may have been used with startling efficiency. In some systems, carbon-rich dust grains appear within the first billion years of cosmic history. That is early enough to feel almost abrupt. Not impossible, but abrupt. And abruptness in science is often where a hidden mechanism waits. If dusty galaxies existed so early, and if some of their dust properties suggest relatively large grains, then astronomers have to ask which production channels can work fast enough. Supernovae become especially important in that context, because they can enrich and seed the environment on comparatively short timescales after massive stars live and die. Large grains formed in ejecta may also have a better chance of surviving some destructive processes than smaller ones. That does not solve every case, and it does not erase uncertainty, but it pushes the story toward a universe in which stellar death began building dusty complexity very quickly. That is a very different picture from the one most people carry around. Not a slow decorative accumulation at the edge of cosmic maturity, but an early, active material economy already underway while the universe was still young enough that many of its larger structures were only beginning to settle into recognizable form. You can feel the strangeness of that if you imagine finding weathered-looking material in a city that was built last week. It would force you to ask how so much texture, so much residue, so much history could have appeared so fast. The analogy is imperfect, but the emotional point holds. Dust in the early universe is not just a detail about composition, it is evidence about pace. And pace changes meaning. Because once the young universe starts to look materially mature in this way, we are no longer dealing with a simple timeline in which complexity politely waits its turn. We are dealing with a cosmos that becomes chemically and structurally rich as soon as the right channels open, and sometimes faster than our neatest expectations would prefer. Dust is part of that acceleration. It is one of the ways the universe stops being abstract and starts acquiring texture. And texture changes everything, because once matter acquires texture, it stops behaving like a blank medium and starts behaving like history made visible. That is especially true when we talk about how dust changes the light of entire galaxies. A distant galaxy does not simply send us a clean message across space. Its starlight passes through material inside that galaxy, and that material changes what reaches us. Some wavelengths are absorbed more strongly than others. Some are scattered. Some energy is re-emitted in infrared. The exact character of that filtering depends on the dust itself, its grain sizes, its composition, its distribution, its environment. So when astronomers speak about dust attenuation, they are not describing a trivial nuisance. They are describing part of the optical personality of a galaxy. A useful way to feel this is to imagine looking at a city at night through different kinds of glass. One window might dim everything evenly, another might shift the colors, another might blur point sources and leave bright halos around them, another could block much of the shorter wavelength light while allowing more red and infrared through. The city has not changed, but your evidence about it has. And if you are trying to infer how many lights there are, how hot they are, how far away they sit, or how the neighborhoods are arranged, the properties of that glass suddenly matter a great deal. Dust is that kind of filter, except the filter is not manufactured and fixed. It evolves. That is another piece of the complexity Webb has helped sharpen. Dust properties do not appear to remain constant across all cosmic time or across all galactic environments. The typical grain populations in one epoch or one type of galaxy may not match those in another. A young system with fresh dust from recent stellar deaths may not look like an older system whose grains have been processed, shattered, coated, regrown, and redistributed across long ages. So the way a galaxy dims and reddens its own light is itself part of the story of that galaxy's maturity. This means dust is not merely something inside galaxies, it is part of how galaxies become legible or deceptive. And that phrase matters because deception, in astronomy, is often just reality seen through incomplete assumptions. If you assume the wrong dust, you can misread the stars, misjudge the rate of star formation, misestimate the energy budget, misunderstand the balance between what is hidden and what is exposed. A galaxy can look younger or older, cleaner or murkier, more active or less active, partly because of what its dust is doing to the message. Dust is not lying. But it can make reality look simpler than it is if we are not careful. Webb's contribution here is subtle but powerful. By extending our reach into infrared wavelengths with much greater sensitivity and detail, it helps separate what was once entangled. Starlight dimmed by dust, thermal glow from dust itself, signatures from molecules and small carbon-rich carriers, structures buried inside opaque regions, all of these become more discriminable. Not perfectly, not in every case, but enough to change the texture of the inference. And once inference improves, the universe starts feeling denser with intention, even though there is no intention there in the human sense. What I mean is that formerly broad categories begin to split. One dusty region is not just dusty, it is layered in a particular way, heated in a particular way, enriched in a particular way, exposed in a particular way. A galactic outflow is not just matter leaving, it is matter sorted by energy, chemistry, and survivability. An early galaxy is not just surprisingly bright or surprisingly mature, it is carrying evidence about which dust production channels were fast enough, which grains endured, which assumptions about timing may have been too comfortable. This is the point where the subject begins to feel almost biological, and it is important not to push that metaphor too far. Dust is not alive, it has no goals, no metabolism, no desire to persist. And yet the patterns surrounding it can feel strangely lifelike because they involve selection, environment, turnover, accumulation, vulnerability, and reuse. Certain forms arise more readily under certain conditions. Some survive where others fail. Some become substrates for later complexity. Some are recycled through systems much larger than themselves. What we are really noticing is not life in dust, but ecology in matter. That may be the cleanest way to say it. An ecology is not just a list of things. It is a set of relationships under conditions that favor some outcomes and suppress others. Interstellar dust belongs to such a network. Radiation fields alter grains. Grains alter cooling. Cooling alters collapse. Collapse alters star formation. Stars then flood their surroundings with light, winds, and eventually ejecta, which alter the dust again. The system loops, not neatly, not universally, but really. This is why the title lands with more force the longer you stay with it. The true complexity of interstellar dust is not simply that it has many ingredients. It is that dust participates in loops of cause and consequence, from the tiny scale of a grain surface to the immense scale of a galaxy. And once a subject enters the realm of loops, simple stories stop working. You can see that even in the way astronomers have to speak more carefully now about what dust is doing in different places. In one region, strong aromatic features might indicate the survival or presence of certain carbon-bearing structures under relatively cooler or shielded conditions. In another, harsher radiation can weaken those signatures. In cold, dense clouds, icy mantles can build up. In shocks, grains can be broken down. In supernova remnants, new dust can form, but later encounters with reverse shocks may destroy part of it. Nothing here is one-directional for long. Production and destruction are braided together. That braid is where the emotional charge of the topic really lives, because braiding means the universe is not divided cleanly into places where matter is made and places where it is lost. The same environment can create and threaten. The same event can enrich and erase. A star can manufacture the heavy elements needed for dust, then later emit conditions that help damage dust nearby. A violent death can both disperse material and seed future structure. A young galaxy can look unexpectedly dusty not because time has become irrelevant, But because some channels are more efficient and some forms more resilient than older expectations allowed, reality becomes harder to simplify. That should not make the subject more distant. It should make it more intimate, because this is how the world often is at every scale we eventually learn to examine properly. What looks static becomes dynamic. What looks uniform becomes varied. What looks like background becomes infrastructure. The pattern is familiar. It is just happening here in a place so far beyond the body that the body resists feeling it. So let's bring it back to feeling. If you stood outside on a winter night and watched your breath disappear into darkness, you would see almost nothing of the air itself. You would feel cold on your skin, maybe wind at your face, but the medium around you would remain mostly invisible unless light, moisture, smoke, or dust happened to reveal it. Human life is built inside media we barely perceive directly. Air, water, atmosphere, fields, flows. We notice them through effects. The interstellar medium is similar in that sense, though vastly stranger. For most of human history, we had no way to feel its weather at all. We could see stars. We could see dark lanes in the Milky Way. We could eventually infer that matter existed between the stars. But the real texture of that medium, its fronts, shells, coatings, carbon chemistry, thermal whispers, layered histories, remained inaccessible. Webb did not make it simple. It made it sensible. That distinction matters. To make something simple is often to shave away its truth until it fits our patience. To make something sensible is different. It is to bring it within reach without denying its richness. That is what the best instruments do at their highest level. They do not just extend vision. They rescue reality from bad intuition. And bad intuition is exactly what the word dust encourages. It makes us think of leftovers, residue, something swept aside. But cosmic dust is often what remains after stars have lived hard lives and what persists long enough to help begin new ones. It stores cold, it changes light, it carries carbon, it wears ice, it marks shells, it rides winds, it records violence, it enables cooling, it enters disks, it becomes part of worlds. The more honestly you look at it, the less it resembles clutter. It begins to resemble continuity, which is why the next question becomes unavoidable. If dust is this entangled with the making of stars, the filtering of light, and the pace of early galactic maturity, then what exactly are we seeing when Webb reveals a dusty structure? Are we seeing an object in the present tense, or are we looking at the overlap of many times at once? Very often, we are seeing both. That is one of the hardest things to feel in astronomy, because sight tempts us into thinking of a scene as a single moment. A photograph feels present, it feels immediate, but dusty structures in space are rarely simple snapshots of one isolated event. They're more like layered exposures, where fresh processes are writing themselves across material that already carries older damage, older chemistry, older geometry. The present tense is real. So is the accumulation. A cloud does not begin as a blank page. A remnant does not expand into untouched nothing. A galactic wind does not rise through a medium with no prior history. Dust moves through all of these places as inherited matter. What we see in one frame may include grains recently formed, grains long reworked, grains coated in cold regions, grains stripped in hot ones, grains moved from somewhere else entirely. So when Webb resolves a dusty region with unusual detail, it is not only revealing shape, it is revealing overlap. That is why some of its most striking images feel almost geological. Not because space and Earth are truly alike, but because both can preserve traces of repeated pressure, deposition, erosion, and disturbance. On Earth, rock layers, dunes, river deltas, and ice cores can record time through structure. In the interstellar medium, the scales are incomparably larger and the mechanisms more alien. Yet a similar intuition begins to emerge. You're not just looking at matter, you're looking at what matter has been through. And the more detailed the view becomes, the more dangerous a simple story becomes. Suppose you see a bright, dusty arc near hot stars. One instinct is to imagine a single process, radiation shaping nearby material. That may be true in part, but the grains in that arc may already differ in size and composition from neighbouring grains because of earlier events. Some may have formed in one environment and been transported into another. Their response to heat and light may depend on what coatings they carry or what damage they have already suffered. The visible structure might reflect both the current assault and the prior condition of the matter being assaulted. In other words, dust has memory without consciousness. It remembers through survival, composition, and placement. A grain that has acquired an icy mantle in deep cold is physically different from one that has spent ages in a harsher field. A larger grain and a smaller grain do not interact with light in the same way. Carbon-rich material and silicate-rich material do not behave identically. If shocks have shattered a population of grains, the resulting distribution changes what that region does to passing radiation. If grains have grown, they alter the optical behavior again. So even before a new event arrives, the medium has a stored condition. That stored condition shapes what happens next. This is part of what makes interstellar dust such a powerful subject once the instrument is good enough. It forces us to abandon the fantasy of isolated causes. The universe is full of inheritance. You can feel that most strongly when looking across cosmic time. An early galaxy does not simply contain the products of the stars currently shining inside it. It also contains the remains of stars that have already lived and died, processed matter from prior episodes of star formation, dust that has survived at least some destructive conditions, and perhaps large grains that preserve clues about how quickly stellar ejecta condensed in those first generations. Even at great distance, where we may only see integrated signals and broad tendencies, the underlying truth remains layered. Every dusty galaxy is a compromise between creation, alteration, and loss. And that is a far more interesting idea than dust is there. Because dust is there makes it sound passive. Dust is inherited changes everything. It means the space between stars is not merely filled, it is burdened, enriched, and patterned by what came before. It means the next generation of structure does not arise from abstract matter, but from matter that already has a biography. And biographies matter. They determine fragility. They determine capacity. They determine what the environment can do with what it receives. This becomes especially vivid in places where Webb lets us compare hidden and exposed material in the same broader region. Areas that look dark in visible light can become radiant in infrared. Places that seemed like absences become concentrations. The immediate lesson is that we were missing things. The deeper lesson is that visibility and reality were never aligned to begin with. That misalignment has philosophical force, but it is also physically practical. If a star-forming region looks torn apart or half-empty at one wavelength and richly structured at another, then our intuitive sense of where matter lives is unreliable. If dust is shaping both what is concealed and what can happen chemically inside that concealment, then misunderstanding dust means misunderstanding the conditions of starbirth itself. Webb has made that problem harder to ignore by showing how much organization can sit inside apparent obscurity. What used to feel like blankness often turns out to be crowding. That sentence applies to more than images, it applies to interpretation. Take the case of dense cold clouds. For years, astronomers built careful models of what kinds of grains and icy mantles might exist there, what sizes they might have, how coatings might alter their behavior. Webb has begun to tighten some of those constraints, giving more direct leverage on the nature of icy grains in interstellar environments. That might sound like a technical refinement, but it is really another collapse of false simplicity. Ice in deep space is not decorative frost. It changes sticking, chemistry, and optical properties. It changes what can accumulate and what can be measured. A grain with a mantle is not merely a grain plus a coating. It is a different participant in the environment. The same is true at larger scales. A galactic wind carrying dust-related material is not simply relocating what already existed. The conditions of that wind can alter what survives the trip. A supernova remnant does not simply produce dust and leave it untouched. Shocks can later threaten part of what formed. A region near hot stars does not just illuminate grains, it sorts them by endurance. Once again, the medium begins to look less like scenery and more like a system of tests. And in systems of tests, the survivors can tell you what the conditions have been. That is one reason carbon-rich signatures and small-grain carriers are so valuable. Even when the exact ontological line between a very small grain and a large molecule becomes awkward in ordinary speech, their presence, variation, and disappearance help map the environment. They indicate where radiation has been harsher, where shielding has helped, where cooler material persists, where matter is being transformed rather than simply observed. Webb's ability to trace those distinctions with unusual sensitivity has made some dusty regions feel less like smears and more like diagnostic fields. The hidden architecture is becoming readable. Not fully, not cleanly, but enough that older, flatter intuitions no longer survive. And this is where the story begins to fold back toward us, because the more dust becomes legible, the more extraordinary our own position starts to feel. We are creatures who evolved under one narrow window of the electromagnetic spectrum, on the surface of one planet, inside one atmosphere, in a biosphere that trained our senses for immediate survival. We were never built to see cold, carbonaceous grains glowing in infrared inside the remains of dead stars. We were not built to notice icy mantles on microscopic solids between stars. We were not built to read galactic winds by the traces of dust they carry. Yet here we are. That matters because every time a new instrument opens a hidden regime, it does more than add information. It exposes the provincial nature of unaided perception. Dust looked simple in part because human seeing is a local compromise, not a measure of reality. The universe did not become more structured when Webb launched. It became less willing to flatten itself to our senses. And once you really feel that, even the oldest dark lanes in the Milky Way begin to change in character. They are no longer just dark interruptions across the stars. They become places where matter is thick enough, cold enough, and organized enough to withhold one kind of light while preparing entirely different futures inside. The darkness itself becomes active, not empty, not mute, preparatory. Which raises a subtler question, and maybe the most beautiful one so far. If dust is preserving memory, shaping chemistry, altering light, and carrying material from one generation of stars into the next, then what we call interstellar dust may be less like residue and more like a bridge between temperatures, between environments, between deaths and births, between the visible universe and the hidden one, between what has already happened and what has not yet formed. A bridge is the right word, as long as we remember that bridges do not have to be elegant to be essential. Interstellar dust is not a polished connector laid down for convenience. It is irregular, fragile in some settings, resilient in others, constantly altered by the environments it crosses. But it does link domains that would otherwise feel separate in the mind. The fiery interiors of stars and the cold chemistry of clouds, violent stellar death and the quiet beginnings of planets, the way a galaxy looks and the way a galaxy evolves. Dust carries the imprint of one phase into the conditions of the next. That is why it becomes harder and harder to treat it as an accessory. A galaxy without dust would still contain stars and gas, but it would not be the same kind of place. Its light would travel differently. Its cold, dense regions would cool differently. Its chemistry would unfold differently. The pathways toward later structures would be altered at every step. Dust is one of those materials that begins by seeming secondary and ends by revealing that the system's behavior depends on it more than ordinary language prepared us to expect. And ordinary language really is part of the problem here. The word star feels grand. The word galaxy feels grand. Even black hole arrives preloaded with drama. Dust does not. Dust sounds negligible before the sentence has even begun. So the mind walks in leaning the wrong way. It assigns importance too early, based on scale and emotional packaging rather than on function. Webb's revelations have been powerful in part because they force a correction in that instinct. They show us a universe in which apparently humble matter can be structurally central. That lesson reaches beyond astronomy. But astronomy is where it becomes hardest to ignore, because out there, consequences are separated from causes by vast distances and long time scales. The systems are too large for direct bodily intuition. We rely on light, spectra, temperature signatures, and structure, and dust is entangled with all of them. It can hide what lies behind it, radiate on its own, reshape the message, carry a record of past processing, and participate in future transformation. It is simultaneously a medium, a tracer, and a participant. Few materials get to be all three. That helps explain why Webb's view feels like more than improved photography. A sharper image alone would have been satisfying, a prettier cloud, a more dramatic remnant, a cleaner look through obscuration. But what has emerged is more consequential than that. The telescope has made dust more diagnostic. A region glowing in a certain way is not merely beautiful. It is telling us about grain behavior, heating, shielding, carbon chemistry, or icy matter. A shell around a stellar system is not merely symmetrical, it is a timeline written in expelled material. A dusty early galaxy is not merely surprising, it is evidence about how fast the universe learned to texture itself. That phrase deserves to stay for a moment. How fast the universe learned to texture itself. Because texture is what turns a schematic cosmos into a real one. It is what breaks the clean lines of a simplified model and replaces them with gradients, fronts, residues, asymmetries, and traces of stress. We often begin understanding by simplifying. That is necessary. But reality becomes emotionally convincing only when the simplifications start to fracture. Webb has accelerated that fracture for interstellar dust. You can see it in the shift from generic cloud to layered medium. You can see it in the move from dust blocks light to dust changes with environment and rewrites what light means. You can see it in the realization that grains are not inert bits of leftover matter but surfaces where important low-temperature chemistry can proceed. You can see it in the fact that dust emerges from multiple production channels, survives unevenly, and then travels into different roles in different settings. Every layer of the story moves away from singularity and toward population, environment, and history. That is what complexity actually feels like when it is real, not complication for its own sake, not jargon, not a pile of exceptions. Complexity is what appears when many true influences overlap, and none of them can be safely erased. And once you know that, some of the most famous images in astronomy become harder to look at innocently. Dark nebulae are no longer just picturesque absences. Bright filaments are no longer just decoration. Dust lanes crossing galaxies are not merely compositional contrast for the eye. They are sites of altered light, stored material, cooled regions, hidden chemistry, inherited grains, and possible futures. A pretty image becomes a denser fact. That change in feeling is one of the great pleasures of good science. The world does not become less beautiful when explanation arrives. It becomes heavier with meaning. Still, it is important not to flatten the uncertainty in the other direction, as if Webb has now solved dust completely. It has not. Some of the most interesting questions remain unsettled. How much dust formed in a given supernova remnant may still be difficult to pin down precisely. How much survives later shocks remains a live issue in many cases. The exact roles of different stellar sources across different epochs are still being refined. The balance between fresh production, grain growth in the interstellar medium, destruction, and reprocessing varies from environment to environment. The early universe remains full of surprises, and some of them will almost certainly force revisions. But uncertainty here does not weaken the narrative, it strengthens it, because the kind of uncertainty we are left with is no longer the uncertainty of ignorance so total that anything could be true. It is narrower, richer, and more honest than that. Webb has closed off many simpler pictures. It has made certain broad claims untenable. Dust is not just a passive veil. Dust is not chemically monotonous. Dust is not confined to one serene kind of environment. Dust is not late cosmetic residue on top of more important cosmic structures. Those doors have largely closed. What remains open are better doors. How exactly do different grain populations evolve under specific combinations of shock, radiation, density, and time? Which early galaxies were dominated by which dust production channels, and when? How quickly can fresh ejecta be reworked? Under what conditions do icy mantles most strongly alter subsequent chemistry? What hidden structures are still waiting in regions we have only begun to resolve properly? These are frontier questions. But they unfold on a foundation that is now much firmer. The medium is intricate, active, and historically loaded. And that foundation changes how we think about time itself in the universe. Because there is a quiet tendency, whenever we talk about stars and galaxies, to imagine time mainly in terms of big landmarks. A star forms, a star dies, a galaxy merges, a planet appears. Those are useful points in the story, but they can accidentally hide the continuous material life unfolding in between. Dust restores some of that continuity. It reminds us that matter is being modified all along, not just at headline events. Coatings build slowly, radiation fields sort populations. Shocks break some grains and spare others. Winds transport material, shells expand. Hidden cold chemistry continues in the dark. Time is not just marked by explosions and births. It is also inscribed in quiet alteration. You can almost think of dust as one of the universe's slower verbs. Not the most dramatic one, not the brightest, but persistent, connective, and quietly generative. To notice it properly is to notice that reality does not only advance through spectacular episodes, it also advances through suspended particles, long exposure, and patient transformation. The huge depends on the tiny more often than our instincts would like. And that recognition prepares us for one of the deepest emotional turns in the whole subject. Because if dust is carrying material across generations of stars, if it is participating in the cooling of clouds and the chemistry of dark regions and the assembly of later planetary systems, then the distance between interstellar dust and ourselves is not as clean as the phrase suggests. We talk about between the stars as if it names a place fundamentally elsewhere, and of course it does. The scales are immense, the conditions lethal, the physics outside the range of the body, but the matter itself is not fully foreign. The heavy elements in those grains are the same kinds of elements that later enter rocks, water-bearing minerals, atmospheres, and living systems. The carbon-rich particles Webb traces in one environment are part of the same larger elemental story that eventually reaches biology in another. Not directly, not romantically, through long chains of processing, dispersal, collapse, and assembly, which means that when Webb reads the thermal whisper of dust in deep space, it is not merely peering into an exotic side chamber of the cosmos. It is observing one stage in the long material prehistory of worlds, and once that enters the mind clearly, the hidden architecture of dust begins to feel less like distant scenery and more like ancestry written in cold light. That word can be dangerous if used lazily, because it invites sentimentality, so it is worth being precise. Dust is not our ancestor in some soft, slogan-like sense. The universe does not become profound merely because we notice that atoms are recycled. That idea is too easy, too polished, too willing to settle for a familiar line. The real feeling is tougher and stranger than that. What Webb reveals is not a comforting poem about our origins. It is a material continuity so long, so indirect, and so severe that it almost escapes emotion at first. Before a rocky planet can exist, before an atmosphere can hold, before chemistry can complicate itself into anything resembling life, there has to be a long prior history of stars making heavy elements, of those elements entering solids, of solids surviving hostile environments, of clouds cooling, of disks forming, of grains colliding and changing and travelling through conditions no human body could endure. Interstellar dust belongs to that prehistory. It is one of the forms matter takes while the universe is still arranging the possibility of places like Earth. That is a colder, truer kind of intimacy. And Webb has sharpened it not by making grand claims, but by making the intermediate stages harder to ignore. It has shown dust where we used to see only concealment. It has shown structure where we used to accept haze. It has shown carbon-bearing complexity in harsh and varied environments. It has shown dust in outflows, in shell systems, in remnants, in young galaxies. It has made the road between stellar death and future worlds feel less abstract, because more of the road is now visible. Visibility matters because imagination is weak when the chain has missing links. We can understand an idea abstractly and still fail to feel it. That often happens in astronomy. We learn that stars make heavy elements. We learn that planets form from disks. We learn that dust exists in between. Each statement is true, but truth presented as disconnected facts remains thin. Webb has begun to thicken that chain by showing the intermediate material states with enough specificity that the sequence acquires texture. It is the difference between reading a family name in a document and seeing several generations in photographs, letters, tools, scars, and inherited objects. The lineage becomes tangible. You can sense transmission, not just assert it. Dust does that for cosmic history. It also reveals something more unsettling about perception itself. Human beings are deeply vulnerable to ranking reality by how directly it presents itself to us. Brightness seems important. Loudness seems important. Big visible shapes seem important. Fine cold grains suspended through dark regions do not. We have to learn, over and over, that our instinctive hierarchy of significance is badly distorted. Some of the most consequential processes in any system happen quietly, diffusely, and out of sight. Webb is one more chapter in that correction. It tells us that the dark is not necessarily empty, that the obscure is not necessarily secondary, and that what interrupts a view may also be what makes later worlds possible. It is hard to think of a clearer example of science expanding not just knowledge, but humility. We did not merely fail to see some details, we failed to rank them properly. We called them dust. That shift becomes even sharper when you consider how long the universe kept this hidden from unaided senses. For most of human existence, the night sky was a surface of lights, extraordinary, moving, myth-laden, mathematically rich, but still mostly a surface. Even after telescopes arrived, much of the medium between stars remained stubbornly reduced, either to darkness or to softened luminosity. We could infer, we could model, we could build spectra and theory, but there is a special kind of conviction that arrives when hidden material stops being hypothetical in the emotional sense and starts presenting itself with form. Webb has given us form. A remnant with layered dust does not simply say, matter is present. It says this matter has been pushed, folded, illuminated, and perhaps stacked along the line of sight in ways that preserve the violence and geometry of past events. A shell around colliding wind stars does not just say dust formed here, it says formation repeated, expanded, and kept the rhythm visible. A cold cloud with constrained icy grains does not only say, ice exists. It says surfaces are changing, sizes matter, and the chemistry of dark regions can no longer be treated as a vague background possibility. A distant young galaxy with surprising dust content does not merely say, the early universe was not pristine. It says the pace of material maturity demands respect. Each case adds detail. Together, they alter worldview. And worldview matters because once you internalize this, the cosmos stops resembling a stage set composed of stars alone. Stars remain central, of course. Their energy, gravity, lifetimes, and deaths are still among the great engines of the universe, but the space between them no longer feels like blank spacing inserted for dramatic effect. It becomes a domain of processing, storage, filtering, and preparation. The architecture of reality thickens. That is one of the reasons this topic lingers so strongly after the facts are done. It is not only about dust, it is about what happens when a category you treated as marginal turns out to be structurally indispensable. That pattern carries a kind of emotional voltage because it forces a reordering of attention. It tells us that reality often hides its leverage in things that seem too small, too scattered, too inconvenient, or too ordinary to matter much. Dust is leverage hidden in plain sight, and the more carefully we follow it, the more we find ourselves crossing boundaries that once felt separate. Physics becomes chemistry, chemistry becomes structure, structure becomes history, history becomes possibility. The life cycle of stars becomes the precondition of planets. The attenuation of light becomes part of galactic interpretation. What started as a nuisance term becomes a bridge between whole domains of understanding. That is not just intellectually satisfying, it is emotionally stabilizing in a strange way, because it makes the universe feel less like a collection of isolated spectacles and more like a continuous material order. Severe, yes. Often violent, yes. But connected. And connection is not the same as comfort. A supernova remnant can be beautiful and lethal. A radiation-bathed cloud edge can host exquisite chemistry and brutal destruction at once. A galactic wind can carry traces of carbon-bearing particles while testifying to furious stellar activity. The early universe can appear materially fertile while still being unimaginably hostile to any human life. None of this is gentle. The point is not that the cosmos is kind. The point is that it is coherent in ways we keep underestimating. Dust is one of the places that coherence becomes visible, which is why it matters that Webb's contribution is cumulative rather than singular. There was no single moment when the telescope solved dust. The title works because the revelation has come from convergence. One observation revealed layered complexity in a remnant. Another tightened the story of icy grains. Another showed rich local variation in carbon-bearing features at irradiated cloud boundaries. Another traced dust-related material in galactic outflows. Another strengthened the case for supernovae as major dust reservoirs. Another followed shell-making around colliding stellar winds. Another exposed surprisingly early carbon-rich dust in the young universe. These are not isolated curiosities. They are multiple windows opening onto the same truth. The medium is richer than the old simplifications allowed. When several independent views keep pushing in that direction, confidence changes character. We may still debate particulars, but the broad picture becomes hard to evade. Dust is not incidental. Dust is not uniform. Dust is not late cosmetic clutter. Dust is one of the ways the universe stores and transfers consequence. That phrase also clarifies why the subject feels so calm and so intense at the same time. Calm, because much of dust's work happens slowly, quietly, and in darkness. Intense, because what it mediates includes stellar death, galactic feedback, hidden chemistry, and the conditions under which later worlds can emerge. It sits at the intersection of patience and violence. Few things do that so completely. And perhaps that is why the images stay with people even when they do not remember the details. Somewhere beneath the technical explanation, the eye and the mind register the same message. Those bands and filaments and shells are not decorative flourishes. They are a medium under pressure. They are evidence that the space between stars has a life cycle of its own. If by life cycle we mean ongoing transformation rather than life in the biological sense. It is not empty distance. It is active interval. The stars are not alone. That sentence lands differently now than it would have at the beginning. At first, it might sound almost sentimental, as if we were trying to soften the loneliness of cosmic scale. But this is not about loneliness. It is about matter. Stars are embedded in, shaped by, and eventually return to a medium that is far more structured than the naked eye ever suggested. Webb has made that embedding visible enough that the old picture of isolated points in darkness can no longer hold. And once that picture breaks, an even larger realization begins to approach. If dust is this central to how the universe hides, remembers, and prepares, then the history of reality may be written less in objects alone than in the media that connect them. That is one of the deepest corrections modern astronomy keeps making. We are naturally drawn to objects, planets, stars, black holes, galaxies. The mind likes nouns with edges. It likes things that can be pointed at, named, bounded, framed. Media are harder. A medium is not always one thing. It is what things move through, what carries force, what alters signals, what stores conditions between events. You usually notice a medium by its effects rather than by its self-presentation. Air becomes obvious when wind rises or smoke reveals its motion. Water becomes obvious when it freezes, floods, or reflects. Interstellar dust belongs to that class of reality. It is easiest to miss until something makes its structure undeniable. Webb has done that. And once a medium becomes undeniable, history changes shape. It stops looking like a chain of separate dramatic episodes and starts looking like a continuity of altered conditions. A star does not simply die, and then somewhere else. Sometime later, another star is born. Between those points lies a material circulation. Elements are dispersed, solids condense, grains survive or do not, clouds cool, shift, and gather. Radiation sorts what remains. Molecules form on surfaces. Disks inherit processed matter. Future planets arise from ingredients that are not pristine, but already weathered by previous stars. Dust is part of the continuity that keeps one event from being isolated from the next. This is where the subject quietly becomes more profound than it first appeared, because once we start thinking in media instead of only in objects, we are forced to care about what persists between headline events. The universe is not built only at moments of ignition and collapse. It is also built in the intervals, in the transport, in the suspension, in the long quiet residence times of matter under changing conditions. Dust occupies those intervals. You could say that stars make headlines, but dust keeps records. That line holds more truth than metaphor. A shell around colliding wind stars is a visible sequence. A dusty remnant preserves the aftermath of an explosion in layered structure. A cloud boundary marked by changing aromatic features records how radiation is sorting its chemistry. A distant galaxy's dust properties encode information about how quickly solid matter emerged and how it has been processed. These are records, though they are written in temperature, recomposition, and geometry rather than ink. and records are most valuable when they preserve things we could never have watched directly. No human being has observed the full life cycle of a dust population unfold in real time from formation through long interstellar processing to eventual incorporation into a planetary system. The timescales are too vast, the environments too many, the transformations too indirect. What we do instead is read snapshots, spectra, shells, remnants, and distributions. We infer histories from surviving traces. In that sense, dust astronomy shares something with archaeology and geology. You do not see the whole sequence happen. You reconstruct it from what endured. The difference is that here the archive is spread through space, and the pages are cold. That may be why Webb's infrared vision feels so intimate when you stay with it long enough. Visible light often gives us the dramatic actors. Infrared frequently gives us the hidden substrate, the cooler matter, the buried structures, the thermal signatures of what would otherwise remain silent. It is not simply peering past obstruction. It is listening to materials that ordinary vision demotes. Dust does not often announce itself the way a star does. It whispers. Webb is unusually good at hearing whispers, and whispers change the moral balance of a story. When only the loudest things are audible, reality seems to belong to force and brightness. When the quiet signals arrive, another order emerges. Endurance matters, cooling matters, coatings matter, transport matters, tiny solids in darkness matter. Suddenly the universe looks less like a contest among obvious giants and more like a system in which thresholds are crossed because subtle conditions were met long beforehand. That is a more mature kind of awe. Not the awe of spectacle alone, though spectacle is certainly there. Not the awe of size alone, though the scales remain immense. It is the awe of realizing that a neglected category can be carrying more structural weight than your language prepared you to notice. Dust looked like residue. It turns out to be one of the ways reality connects itself across time. That idea reaches its clearest form when we return to early galaxies. Webb's observations at great distance have repeatedly reminded astronomers that solid matter, carbon-rich grains, and complex attenuation behavior can appear startlingly early. No one serious claims that every detail is settled. They are not. Some galaxies challenge models more than others. Some interpretations remain provisional. Yet the broad lesson remains powerful. The young universe was not waiting politely to become textural. It was already making and moving dust on timescales that forced us to revisit our assumptions. And assumptions about timing are really assumptions about capability. If dust appears early, then some channels for producing and preserving it are more effective than older expectations allowed. If large grains are present in some young systems, then the material life of the early cosmos may have been robust in ways that change how we imagine its pace. If carbon-rich grains already exist in the first billion years, then chemistry with future consequences has arrived, while the universe is still in comparative youth. Dust becomes one of the clearest signs that complexity does not always wait for old age. The cosmos can become intricate very young. That is an emotionally strange thought. We tend to link maturity with slowness, seasoning, long accumulation, and often that is right. But there are also systems where the right mechanisms open and complexity accelerates. The early universe appears to have been one of those. Once stars began forging heavy elements and dying, the material economy changed. There was a path, still being mapped in detail, still debated in places, by which dust could emerge, survive enough, and begin influencing what followed much sooner than a simplified mental timeline would suggest. That acceleration is not chaos, it is responsiveness. Given the right ingredients and forces, the universe does not hesitate to elaborate itself. And that word elaborate is useful because it avoids two mistakes at once. It avoids the cheap claim that reality is trying to become beautiful for us, and it avoids the dead claim that reality is just particles doing nothing meaningful. Elaboration is what systems do when many processes begin interacting. Dust belongs to that elaboration. It thickens the story of light, of chemistry, of cooling, of memory, of inheritance. Once you really feel that, you begin to understand why one telescope could change the emotional character of an old subject without overturning every previous result. Webb did not arrive to tell astronomers that dust exists. They knew that. It arrived and made dust harder to simplify, harder to flatten, harder to leave in the category of secondary complication. It rendered the old understatement unstable. That kind of scientific progress is often more important than a single dramatic upset. Not every revolution comes from replacing one clean answer with another. Some come from exposing how much richness was hidden inside a category everyone thought they already understood well enough. Dust is one of those categories. It looked familiar. It was not. And perhaps this is the moment to notice how much our own emotional journey has followed the material one. We began with contempt built into a word, dust as nuisance, as residue, as what settles after the important action is done. Then structure appeared, then chemistry, then survival and destruction, then shells, outflows, and early galaxies, then continuity. By degrees, the meaning of the word changed. Not because the language changed, but because the reality inside it became too large for the original instinct. This is one of science's quiet mercies. It rescues dismissed things from bad naming. That rescue matters because bad naming is a form of blindness. When we call something dust, or noise, or background, we're often revealing a weakness in perception before we're revealing anything about the thing itself. Webb's images and spectra are corrective acts against that weakness. They say gently but firmly that the dark medium between stars is not an afterthought. It is part of the universe's ongoing method. Method may sound too tidy. The cosmos has no intention, no plan, no desire to become interpretable. But it does have recurring processes, and dust is woven into many of them. It helps light become misleading and therefore informative. It helps clouds cool and therefore collapse. It helps chemistry settle onto surfaces and therefore proceed differently than it would in open gas. It carries evidence of stellar life and death. It becomes part of disks and worlds. It belongs to the means by which the universe gets from one state to another. So when Webb reveals a dusty structure now, we should not ask only what we are looking at. We should ask what transitions we are seeing held together long enough to become visible. That question is larger than it first appears, because transitions are usually what the eye misses. We notice completed forms, a mountain, a building, a planet, a star. We are much worse at perceiving the suspended states in between, the sediment carried before the delta forms, the moisture before the storm breaks, the dust before the world appears. Yet those in-between states are often where the future is being prepared. Interstellar dust belongs exactly there. It occupies the unstable interval between what has already happened and what has not yet taken shape. That is one reason Webb's observations carry such unusual emotional weight. They reveal not just things, but preparations. A cold, dusty region is not merely a patch of matter. It may be a place where chemistry is accumulating on surfaces, where cooling is helping gravity gain leverage, where hidden material is waiting for a later transformation. A shell around massive stars is not just an ornament in space. It is matter on the move, preserving episodes, drifting outward into environments it may later affect. A dusty outflow from a starburst galaxy is not just expulsion, it is redistribution. The universe is full of preparations. That line sounds almost gentle, but what it points to is severe. Many of those preparations occur through crushing pressure, radiation damage, shock, erosion, collision, and the relentless filtering of which materials can endure which conditions. Dust does not connect phases of cosmic history by gliding neatly from one role to another. It is tested, it is altered, it is sometimes obliterated. The bridge it forms is real, but it is not smooth, which makes its persistence more meaningful, not less. We usually reserve the word persistence for living things, institutions, memories, intentions. But matter can persist structurally too. A grain survives long enough to be coated. A larger grain survives where a smaller one fails. Carbon-bearing material remains in a region where harsher conditions elsewhere have stripped it away. Dust endures through enough of the cycle to pass consequences forward. When that happens across vast populations and long time scales, persistence becomes history in motion. And history in motion is what Webb keeps catching. It catches it in the wood-grain-like layering of remnants, where what might once have looked like diffuse debris now suggests sheeted structures, fronts, and folds. It catches it in the aromatic signatures that shift across cloud boundaries, indicating that radiation is not merely lighting the region but chemically organizing it. It catches it in the shells around colliding wind stars, where repeated dust formation makes time visible as spacing. It catches it in early galaxies, where the presence and character of dust make a statement about how quickly stellar processes were already elaborating the young cosmos. Everywhere you look, the same correction returns. Dust is not what remains after the story. Dust is one of the ways the story continues. And once you feel that properly, even the phrase interstellar medium changes its emotional character. Medium can sound abstract, almost technical, as though it refers to a neutral container. But no real medium is ever perfectly neutral. A medium transmits, filters, buffers, stores, and reshapes. Air carries sound and weather. Water carries heat and sediment. The interstellar medium carries the consequences of stars and helps determine what stars can form next. Dust is one of the reasons it has those powers. That framing helps with another misconception too. People often imagine astronomy as the study of isolated grand objects floating in emptiness. It is understandable. The night sky offers points of light against blackness, and our minds are drawn to the points. But the more precisely we observe, the less satisfying that picture becomes. The emptiness is not nothing. The darkness is not absence in the simple sense. Between the stars lies a medium with gradients, fronts, particles, chemistry, and memory. Once you know that, the old image of lonely lights in a void starts to feel like a child's first sketch of a much denser truth. And this is where the subject begins to repay patience in a different way. Up to now, the revelations have been scientific and structural, but there is also a psychological revelation embedded in them. It concerns what we are like as perceivers. Human beings are not just limited in what we can see, we are limited in what we expect to matter. Our intuitions are shaped by life at one scale, in one temperature range, in one chemical environment, under one narrow band of visible light. We trust edges too much. We trust brightness too much. We trust what can be named quickly too much. Dust embarrasses those habits. It asks us to care about distributed matter, faint signatures, hidden surfaces, and consequences that unfold far from direct experience. That is a difficult ask. It requires a kind of disciplined humility, because the first impulse of the mind is often to return to stars, to the obvious anchors, to the luminous nouns. But Webb keeps refusing that retreat. It keeps showing that the supposedly secondary medium has its own structures, its own clues, its own forms of agency in the physical sense. Not intention, again, but efficacy. Dust does things. It alters outcomes. That distinction between intention and efficacy matters because it protects the subject from sentimentality. We do not need to pretend the universe is alive in some mystical way to feel wonder here. The wonder lies in material consequence. Tiny grains, different in size and composition, shaped by radiation and shocks, carrying ices or carbon-rich structures, can influence how clouds cool, how chemistry proceeds, how light is filtered, how galaxies are interpreted, how early cosmic maturity is understood. That is enough. More than enough. It is also enough to change how we think about scale. We often imagine scale as a ladder of importance. Bigger means more powerful, smaller means less consequential, but dust keeps breaking that ladder. A galaxy is immense. Yet the way it appears and evolves depends partly on grains too small to see individually. A supernova is among the most dramatic endings in the universe. Yet part of its legacy may reside in the dust it leaves behind and the fraction of that dust that survives. The early universe is a story told across billions of light years, yet some of the key evidence comes down to what sorts of grains existed, how large they were, and how they changed a galaxy's light. Small things are not merely inside large systems. Sometimes they govern what large systems can become. That is not a mystical insight, it is a scientific one, and it happens to carry emotional force because it contradicts a very old bias in human thought. We confuse visibility with importance. We confuse grandeur with leverage. Webb's dust observations are one more reminder that leverage is often hidden in fine structure. A grain surface in deep cold can host chemistry. A grain population can alter cooling. A dust distribution can reshape the reading of a galaxy. A shell can preserve cycles. A remnant can retain reservoirs. A wind can carry dusty material out of a galactic disk. A young universe can become textural faster than expected. Each statement is small. Together, they are a worldview. And that worldview changes the feeling of time as much as the feeling of space, because dust teaches us that the universe is constantly carrying partial results forward. Nothing emerges from nowhere. Even novelty inherits conditions. A new star forms from matter already altered by previous stars. A planet forms from solids with prior histories. A distant galaxy's light arrives pre-filtered by material, shaped by processes that may already have repeated across generations. Time does not wipe the slate clean between episodes. It leaves residue, and the residue matters. There is something almost ethical in that, though not in the moral sense. More in the sense of discipline. It asks us to respect continuity, to recognize that what looks minor now may be the substrate of what looks major later. Dust is continuity made difficult to ignore. This is why the title's promise keeps deepening instead of resolving all at once. The true complexity of interstellar dust is not a secret hiding behind a single dramatic image. It is a chain of realizations. Dust has structure. Dust has chemistry. Dust has multiple origins. Dust survives unevenly. Dust is carried across scales. Dust appears early. Dust changes the reading of galaxies. Dust links stellar death to future worlds. Dust exposes the limits of human intuition. The complexity is cumulative because reality is cumulative, and cumulative truths are often the ones that stay with us longest. A spectacular fact can flash and disappear. A reordering of perception lasts. Once you truly understand that a dark lane in space may be crowded with hidden material, cold chemistry, inherited grains, and future consequences, you do not go back to seeing it as decorative darkness. Once you understand that a dusty shell around massive stars is a time record in matter, you do not go back to seeing it as symmetrical scenery. Once you understand that early galaxies may owe part of their appearance to dust made rapidly by stellar deaths, you do not go back to imagining the young universe as a clean, simple stage. The universe remains itself, but your ranking of what matters changes. And that may be the most honest definition of revelation in science. Not magic, not a violation of the old world, a rearrangement of importance inside the same world until the familiar becomes newly dense. Dust has undergone that rearrangement, or rather, we have. Webb simply made it harder for us to resist. And resistance was always part of the story. Not resistance in the political sense, or the institutional sense, though science has its share of those pressures too. A more intimate resistance than that. The resistance of the mind to distributed importance. The reluctance to grant central status to what seems diffuse, cold, and inconveniently hard to picture. Dust asks too much of human intuition. It is easier to care about a blazing star than a population of microscopic grains. Easier to tell a story about a supernova than about the solids that condense later within its aftermath. Easier to admire a galaxy's shape than to think about the dust that alters the very light by which that shape is judged. So when Webb keeps returning dust to the center of the frame, it is not only revealing external reality, it is exposing a weakness in our habits of attention. That is worth dwelling on because the weakness is common to many scales of life. We underestimate what is slow, backgrounded, dispersed, or only visible through indirect effects. We notice outcomes more readily than conditions. We celebrate events more readily than media. Yet conditions and media are often where the real leverage hides. Astronomy does not merely teach that lesson abstractly. It lets us watch the lesson become visible in one of the largest possible settings. Dust is a condition that became visible. And once conditions become visible, causality gains depth. A star-forming region is no longer just a place where gravity happened to win. It is a place where cooling, shielding, composition, grain populations, and the prior history of matter helped shape what gravity could do. A galaxy is no longer just a swarm of stars arranged in space. It is also a system whose dust content and dust character affect how starlight escapes, how energy is redistributed, and how we interpret what is taking place inside. A young universe is no longer just a timeline of early stars and growing galaxies. It is also a landscape in which solid grains emerged, survived enough, and began thickening the material life of the cosmos with surprising speed. This is the point where explanation starts to feel almost architectural, not because the universe is designed, but because once the hidden supports are revealed, you can no longer look only at the facade. Dust is one of the supports. Remove it from the story, and much of the structure above it changes character. Imagine walking into a cathedral and being told for years to admire only the windows and the height of the ceiling, while ignoring the weight-bearing system that makes the whole interior possible. The beauty would still be real, but it would be incomplete. Webb has done something like that for interstellar dust. It has not replaced the luminous windows of the cosmos. It has shown more of the load-bearing material. And load-bearing material is not always attractive at first glance. It may be dark, rough, or hidden behind more dramatic features. That is almost exactly the point. The category we dismissed as obscuring residue turns out to be one of the things helping carry the long continuity of cosmic structure. Even the way dust interacts with light becomes more moving once you understand it this way. Earlier, dust often appeared in the popular imagination as the enemy of observation. It blocked the good view. It got in the way. But a more mature understanding says something different. Dust certainly can hide. It can complicate what we're trying to infer. Yet that same tendency is itself information. The absorption, reddening, and re-emission of light are not accidents to be resented. They are how the material speaks. This is another quiet reversal. The obstacle becomes the message. Not always fully, not without careful analysis, not without the risk of overinterpretation if one is careless, but enough that the old frame no longer holds. When a region dims or glows in a certain pattern, when certain signatures appear and others fade, when the infrared structure of a remnant reveals layered dust and gas, when carbon-bearing features trace cooler material or changing environments, the difficulty of seeing is inseparable from the possibility of understanding. Dust hides, and in hiding it reveals what kind of material is there and what conditions are acting on it. That is a surprisingly intimate thing for matter to do. Not intimate in the emotional sense of kindness, more in the sense that it lets us read circumstance through interference, like hearing the shape of a room through the echo that distorts a voice, or understanding the weather by the way smoke bends in the air. The disturbance is the clue. Dust is one of the universe's great distorters, and therefore one of its great informants. Webb's power lies partly in its refusal to choose between those roles. It can look past some dusty obscuration, yes, but more importantly, it can also read the dust itself as structure, temperature, chemistry, and process. That dual capacity is why the telescope's contribution feels so decisive. It does not only cut through the medium, it dignifies the medium. And dignity is not too strong a word here, because the subject needed rescuing from trivial language. There are many scientific concepts that arrive with built-in grandeur. Dust does not. It arrives almost apologizing for itself. Yet when you follow it honestly, it touches stellar evolution, molecular chemistry, star formation, planet formation, galactic outflows, high redshift astronomy, and the interpretation of a light across cosmic time. Very few supposedly minor categories reach into so many major ones. This is also why dust can make the universe feel calmer rather than merely more complicated. That may sound strange. Complexity usually sounds like clutter. But the kind of complexity Webb has revealed is not random mess. It is structured interdependence, different forms, environments, and timescales interacting in ways that explain more, not less. Once you learn how to read them, the cosmos becomes denser, but also more coherent. A coherent world is easier to inhabit emotionally, even when it is severe. And severe it remains. We should not sentimentalize the environments that make and unmake dust. Stellar winds are not gentle. Radiation fields do not negotiate. Supernova remnants are not peaceful nurseries. Galactic outflows are not benign breezes. The temperatures involved in cold cloud chemistry are far beyond anything a body can bear. The scales dwarf human experience at every turn. But the severity has pattern. It is not arbitrary. Dust gives us one of the clearest ways to see that pattern, because it bears the marks of what has acted upon it, and passes consequences onward. In that sense, dust is almost a witness material. Not a witness because it testifies intentionally, but because it retains evidence. A witness material is any substance whose present condition tells you something about the forces it has encountered. Burned metal, warped stone, tree rings, ice cores, sedimentary layers. Interstellar dust belongs in that family, though at cosmic scale and under exotic physics. Its composition, size distribution, coatings, destruction, survival, and arrangement all preserve clues. Webb has made some of those clues more accessible than ever, which means the telescope has not merely enlarged the stage, it has improved the archive. That is a beautiful shift, because archives change how we feel about time. Time is less frightening when it leaves traces we can read. It becomes less like a blind erasure and more like a layered accumulation. Dust offers that kind of accumulation. Not perfect, not complete, but enough to let us reconstruct pieces of an otherwise inaccessible continuity. It lets us trace how one phase of the universe feeds the next. And feeding the next is perhaps the deepest function of all. Dust gathers from prior stars and then helps shape conditions for future ones. Dust is manufactured under certain extreme circumstances and then participates in calmer, colder chemistry elsewhere. Dust emerges from violence and later enters environments where worlds may begin. The same material category can therefore belong to endings and openings at once. That alone would make it profound. Webb has made it visible enough to feel. You could say that interstellar dust is where cosmic memory and cosmic preparation overlap. Memory, because it bears the marks of what has already happened. Preparation, because it helps set conditions for what comes later. Those two roles are inseparable in the best observations. A shell is a record and a dispersal. An icy grain is a product of deep cold and a site of future chemistry. A dusty high redshift galaxy is evidence of rapid prior enrichment and a clue to how early structure was already becoming materially complex. A remnant is aftermath and supply. The overlap is the point. And perhaps that is why this subject feels so satisfying at length. It never collapses into a single mood. It is not merely awe, not merely mystery, not merely explanation. It carries all of them in changing proportions. There is the awe of hidden structure, the mystery of incomplete frontier questions, the explanation of chemistry and light, the severity of destructive environments, the intimacy of material continuity, the calm of patterned process. Dust does not support a flat emotional response because it is too many things at once. By now, the old insult inside the word has almost become difficult to remember. That is one of the surest signs that perception has changed. A term that once suggested residue now suggests connection, filtering, survival, and stored time. We have not exhausted it. We have not solved it. But we have crossed a threshold where simplification no longer feels innocent. And when simplification stops feeling innocent, the mind becomes ready for a final widening of perspective. Because the largest thing Webb may have revealed about interstellar dust is not any one image, any one remnant, any one early galaxy, or any one shell. It may be something more universal than that. It may be that reality itself becomes more truthful when we stop organizing it around only the brightest objects and start paying attention to the media that connect them. That shift is larger than astronomy, but astronomy gives it a purity that is hard to find anywhere else. On Earth, our attention is constantly captured by urgency, utility, and noise. We live among objects designed to demand us back. In the cosmos, at least from a human distance, there is a little more honesty. Stars burn, clouds cool, dust forms and breaks and drifts and gathers, indifferent to whether we notice. When an instrument finally allows us to notice properly, the correction feels clean. No human motive is hiding inside it, only our own earlier blindness. And blindness is exactly the right word, because the issue was not merely lack of detail, it was a mismatch between the structure of reality and the structure of our seeing. We are drawn to sources, to bright centers, to named bodies, but many systems are governed as much by what lies between the centers as by the centers themselves. Interstellar dust is one of the clearest examples. The stars are dramatic. The medium between them is decisive. That sentence would have sounded abstract at the beginning. Now it should feel almost obvious. The medium changes what light survives and what disappears. It regulates, in part, how cold regions can become, and therefore how readily some clouds can collapse. It hosts chemistry on surfaces under conditions open gas would not reproduce in the same way. It carries the products of stellar death into later environments. It marks cycles around unstable stars. It rides galactic winds. It appears, surprisingly early, in a young universe that was elaborating itself faster than many simplified intuitions expected. Dust does not merely accompany the cosmic story, it changes its terms. And because it changes the terms, It also changes the kinds of questions we ask. A simpler age of understanding might ask where the stars are, how bright they are, how far away they are, how many there are. Those remain essential questions. But once dust becomes central, new questions rise alongside them. What grain populations are present here? How have they been processed? What kind of attenuation is reshaping the light? Are these carbon-rich carriers surviving or being stripped? Is this cold material building icy mantles? How much of the dust in this remnant formed recently? And how much will survive later shocks? What does this dusty early galaxy imply about the speed and channel of enrichment? The hidden medium turns the universe from a map of objects into a map of interactions. That is an adult form of wonder. A younger wonder is often satisfied by spectacle alone. Something is very bright, very large, very violent, very distant. That has its place. But a mature wonder notices conditions, inheritance, and interdependence. It becomes captivated not only by what appears, but by what makes appearance possible. Dust draws us into that deeper register. It asks us to care about the support system, the filtering layer, the thermal whisper, the patient bridge between episodes of obvious drama. Perhaps that is why the subject grows calmer as it grows larger. The more you understand dust, the less the cosmos feels like a sequence of disconnected fireworks. It starts to feel like a severe but continuous material order, one in which nothing truly stands alone. Stars are born from matter already worked on by previous generations. Light reaches us altered by grains with histories. Galaxies vent dust-bearing material into surrounding space. Cold cloud interiors prepare later states in darkness. The apparent intervals between events are not idle. They are full of carrying, sorting, cooling, recording. If we have learned anything from Webb here, it is that the interval is not empty. And that realization touches something very human, because so much of a life is lived in intervals, not at headline moments, not at obvious climaxes, but in the in-between states where conditions are quietly shifting. The analogy should not be pressed too hard. Cosmic dust is not a parable written for us, but there is still a resonance in the pattern. The unnoticed substrate matters. The thing that seems secondary may be load-bearing. The process that looks slow may be setting the terms for everything that follows. Science becomes emotionally powerful when it can say something like that without lying. Dust lets it say it truthfully. It is also worth noticing how much humility is contained in the fact that none of this required the universe to change. The stars did not suddenly begin making more meaningful remnants because Webb launched. Cloud boundaries did not suddenly become chemically varied. Early galaxies did not suddenly acquire dust. What changed was access. The hidden structure was already there. The true complexity was not created by observation. It was revealed by better seeing. There is something deeply grounding about that. Reality does not need our recognition to become rich. It is already rich. Instruments do not grant importance. They expose it. That is why this story feels bigger than a telescope and smaller than one at the same time. Bigger, because it speaks to a general law of discovery. Many of the world's most consequential processes live beneath the scale or mode of ordinary intuition. Smaller, because the details matter. Infrared wavelengths matter. Grain sizes matter. Carbon-rich signatures matter. Icy mantles matter. Shock survival matters. A shell's spacing matters. The exact character of attenuation in a distant galaxy matters. Grand insights become trustworthy only when supported by disciplined attention to particulars. Webb has offered both. It has given us sweeping correction and fine-grained evidence. The large statement is that interstellar dust is far more layered, active, and historically consequential than most people imagine. The detailed support comes from remnants, cloud interfaces, shell systems, outflows, early galaxies, and the changing signatures of dust across environments. This is why the title lands honestly. Not because one dramatic image did all the work, but because many lines of evidence now converge on the same reordering of importance. Dust was never simple. We were. That is one of those short lines that gains force only after the slower journey around it. At the start, it might sound rhetorical. Now it should feel diagnostic. The oversimplification was ours. Reality had always been keeping more records, carrying more consequence, and layering more histories into the medium between stars than our older views could properly absorb. And once that lands, even the visual language of the cosmos begins to shift. Filaments are no longer merely beautiful lines. They are traces of pressure, flow, or inheritance. Dark lanes are not just absences but concentrations. Shells are not just patterns but timings. A dusty glow in infrared is not merely warm enough to be seen. It is matter announcing its state. A reddened galaxy is not merely aesthetically altered, but materially interpreted through its own dust. The universe becomes less pictorial and more physical. That may sound like a reduction, but it is the opposite. To say a thing is more physical in this context is to say it is more fully itself. It is not a decoration for our imagination. It is a system with consequences that can be traced. The beauty does not evaporate under that pressure. It deepens because now the beauty is connected to causality. Structure is no longer just seen. It is understood as earned. Earned by pressure, earned by time, earned by the crossing of matter through violent and quiet states alike. And perhaps that is the final service dust performs in our imagination. It repairs continuity between extremes. The universe is often described through its most dramatic opposites: blazing stars and frozen darkness, explosive death and delicate chemistry, vast galaxies and microscopic grains. Dust belongs in the middle of those opposites. It passes between them. It carries one into another. It proves that cosmic history is not composed only of contrast, but of transfer. Transfer may be the most important word yet. Energy transfers, elements transfer, material transfers, conditions transfer, consequences transfer. Dust is one of the vehicles of that transfer. Not the only one, but an unusually revealing one because it can be tracked through light, structure, chemistry, and time. It lets us see continuity where the eye prefers separation. It lets us see preparation where the eye prefers finished form. By now, the phrase interstellar dust should feel almost too narrow. The term survives because language is efficient, not because it is adequate. What we are really talking about is a family of solid particles and coatings, of carbon-rich structures and silicate grains, of fragile surfaces and surviving populations, of matter that has lived through radiation, collision, freezing, ejection, and dispersal, and that still participates in what the next cosmic phase can become. Dust is simply the old word that remains after the category has outgrown it. And yet perhaps it is good that the word remains humble. It reminds us how often reality hides its deepest intricacy behind names that sound too small. There is a kind of protection in that. The universe does not advertise its most interesting truths with branding. Sometimes it leaves them in ordinary words until better instruments and better patience force us to take those words seriously. Webb has done that here. It has taken one of the most dismissive words in astronomy and filled it with structure, chemistry, timing, inheritance, and consequence. It has made the medium between stars feel inhabited by process. It has turned what many imagined as obstruction into one of the clearest records of how the cosmos makes use of its own past. And once that record becomes visible, the story of stars, galaxies, and worlds begins to read differently all the way through. Because what lies between things is often part of what makes the things possible. That thought is simple enough to miss. We are trained, almost from childhood, to think in terms of separate entities, this planet, that star, those galaxies. The object is what gets the noun, the picture, the story. The medium in between gets treated as spacing. But spacing is not the same as emptiness, and emptiness is not the same as irrelevance. Dust has become one of the most compelling demonstrations of that distinction. It turns interval into substance. And substance changes emotional distance. A star seen across a gulf of blackness can feel remote in a nearly absolute way. A luminous fact detached from us by scale. But once the blackness starts to reveal suspended matter, gradients, transported material, hidden cooling, and stored consequence, the scene no longer feels quite so cleanly divided. It remains distant beyond comfort. Of course, no amount of insight makes the cosmos physically near, yet there is a different kind of nearness that understanding can create, not spatial closeness, but continuity. The star is not isolated from the cloud is not isolated from the grain is not isolated from the chemistry on its surface, the chemistry is not isolated from the future disk. The future disk is not isolated from the possibility of a world. Continuity is a form of nearness, That is part of why this subject leaves such a residue when it is told properly. It changes not only what you know, but how connected the universe feels without becoming sentimental. The connection is not emotional projection, it is material sequence. Heavy elements forged in stars do not leap directly into planets and life in one elegant gesture. They pass through difficult intermediate states. Dust is one of those states, and Webb has made those intermediates more vivid than they used to be. That is a major gain in honesty. The simplified versions of cosmic history that most people carry around are not wrong so much as too frictionless. Stars make elements, elements make planets. Planets can host life. Fine, true in broad outline, but the actual road is rougher, colder, and more intricate. Matter condenses into grains under specific conditions. Some of those grains are carbon-rich, some silicate-rich, some coated, some bare, some fragile, some more durable. Radiation and shocks can sort them. Clouds cool partly through processes in which dust plays a role. Surface chemistry in cold space changes what molecular inventories become possible. Early galaxies may already contain dust from fast enrichment channels. Outflows can carry dusty material far from where it formed. By the time a rocky world exists, the matter involved has often lived several severe lives. The universe does not skip the middle. That sentence may be the quiet heart of the whole story. Webb did not reveal a decorative side issue. It revealed more of the middle, more of the carrying, more of the filtering, more of the hidden preparation. Dust is one of the reasons the middle matters, because it sits in those long transitions where most public-facing versions of cosmic history tend to speed up. The telescope has slowed us down in exactly the right place. It has made the intermediate stages harder to compress into blur. That slowing down is one of the best things science can do for perception. When you're forced to attend to the middle, causality grows roots. You stop mistaking a story's outline for the full reality of the process. The same is true in any serious field, but astronomy has a special power here because the scales are so large and the invisibility is so extreme. Without instruments like Webb, the temptation to flatten is overwhelming. With them, flattening becomes harder to defend. And that has consequences beyond factual accuracy. It affects mood. A flattened cosmos can feel either sterile or melodramatic. Sterile if all you see is empty distance between bright points. Melodramatic if you focus only on the most explosive episodes and reduce everything else to spectacle. Dust resists both distortions. It gives the universe texture without sentimentality and continuity without false comfort. It says that the dark is active, the obscure is consequential, and the in-between is where many of the slow prerequisites of future structure are being assembled. That is a more habitable truth than it may sound. Not habitable in the sense of kindness. The environments remain far beyond us, but habitable to thought. A universe that carries its own consequences forward through media and processes feels more intelligible, more coherent, less like a series of disconnected miracles. Dust contributes to that coherence. It is one of the places where the cosmos reveals that what follows is often built out of what remains. And remains is a much stronger word than leftovers. Leftovers sound accidental, the remains sound historical. The remains of stars become dust. The remains of cold chemistry on grain surfaces become molecular possibilities. The remains of grain populations filtered by radiation become clues to environment. The remains of early stellar generations alter the appearance and evolution of young galaxies. Each use of the word carries a different tension. Something is over, and yet something has been retained. Dust lives inside that tension. It is therefore one of the best materials for teaching the difference between destruction and ending. We often use those words as though they were identical, but they are not. A thing can end and still transmit. A star can die and still enrich. An explosion can destroy and still supply. Radiation can erode one population of grains while leaving another to carry evidence onward. Dust occupies the aftermaths where ending becomes transfer instead of simple disappearance. Once you see that, supernova remnants change character yet again. They are still violent remains of catastrophic stellar death. That does not soften. But they are also places where some fraction of the star's heavy element legacy can condense into dust reservoirs. The remnant becomes not only a monument to what has been lost, but a site where part of the loss is converted into future material usefulness. A very harsh usefulness, but real. The same layered logic applies in less explosive settings. A colliding wind system may look almost too violent to host the quiet formation of dust. Yet rings appear. Cloud boundaries hammered by radiation may still preserve islands or gradients of carbon-bearing complexity. A galactic wind seems like dispersal, yet what is dispersed may influence later environments. The pattern keeps repeating. Severe conditions do not prevent continuity. They sculpt the form continuity can take. That is one of the reasons dust is so difficult to fit into a tidy narrative. It keeps crossing categories. Is it product or participant? Record or agent? Obstacle or clue? Fragile or persistent? Local or cosmic? The honest answer keeps being yes, depending on the place, the process, the time scale, and the grain population in question. Webb has made those crossings more vivid by showing us that one region's dust story may be radically unlike another's, while still belonging to the same larger material cycle. So the complexity revealed is not simply a matter of more details, it is the exposure of plurality inside what looked singular. That distinction matters because almost anything can be made to sound more impressive by adding detail. But true complexity is different. It means the category itself breaks open. Interstellar dust is not one sort of thing behaving one way. It is many kinds of grains and grain-like carriers, in many environments, with many histories, participating in many transitions. Once that becomes visible, the mind has to abandon one-size-fits-all intuition and replace it with something more relational. The relational view is ultimately what Webb is teaching here. Do not ask only what this dust is. Ask what this dust has been through. Ask what environment it is in now. Ask what light is doing to it. Ask what chemistry it can host. Ask what it is hiding. Ask what it is emitting. Ask where it may have come from. Ask what future state it may help make possible. Each question takes us away from static description and into process. And process is where reality becomes most difficult and most satisfying. An object can be admired. A process has to be understood. Dust begins as an object category in language, but in truth it is a process category. It names matter in motion through conditions, matter under selection, matter between roles. Which is why, by now, the old picture should feel almost impossible to return to. Interstellar dust is not a faint nuisance smeared across the important parts of the universe. It is one of the important parts, not louder than stars, not more fundamental than gravity, but woven into enough key transitions that any serious picture of cosmic history has to grant it a central place. Webb did not invent that centrality. It made it harder to overlook. And once centrality has been granted to something this humble in name, the universe itself begins to feel slightly altered, as though one of its hidden load-bearing beams has stepped out of shadow and allowed the rest of the structure to be seen more honestly. That is not the end of the story. It is the beginning of a different way of looking, one that asks what else in reality we keep calling background simply because we have not yet learned how to read it. That may be the most durable gift of a discovery like this. It does not only enlarge one's subject, it trains perception for others. Once you have watched a supposedly minor category unfold into structure, chemistry, timing, inheritance, and consequence, you become less willing to trust first impressions elsewhere. You become more suspicious of clean foreground-background divisions, more aware that the thing obscuring a view may also be part of the mechanism, more attentive to the possibility that a distributed medium, precisely because it lacks dramatic edges, may be doing some of the deepest work in the system. Dust earns that suspicion honestly. What makes it so persuasive is that its significance appears at every scale of interpretation. At the smallest practical scale, a grain surface matters because surface chemistry in cold environments can alter molecular possibilities. At a somewhat larger scale, grain populations matter because they influence cooling, and therefore the conditions under which clouds can collapse. Larger still, dust structures and signatures matter because they reveal local environments, radiation fields, and processing histories. Larger again, galactic dust matters because it changes what light escapes, what gets hidden, and how we infer the activity inside whole systems. Farther out in time, early dust matters because it records how quickly the universe was able to enrich itself and become materially textured. The same category keeps reappearing with different force. That is one of the hallmarks of something fundamental, not the only hallmark, but an important one. Fundamental things do not stay politely in one corner. They keep turning up wherever transitions matter. Dust turns up in the making of stars, in the reading of galaxies, in the chemistry of cold clouds, in the aftermath of stellar death, in the behavior of outflows, in the material prehistory of worlds. The details change, the environments change, the questions change, but the category persists. And persistence across domains is often where intellectual respect begins. It is also where emotional respect begins, though we seldom admit it that plainly. We tend to feel differently about a thing once we realize it keeps quietly governing outcomes in places we assumed were controlled by more obvious actors. Dust has that effect. At first it seems too humble for real grandeur. Then it keeps appearing at hinges in the story until grandeur itself starts to look like the wrong metric. Function becomes more interesting than spectacle. That is a healthy correction, not only for science, but for the imagination. Because spectacle has a weakness. It can command awe without understanding. A supernova can stun the mind even if you know very little about what follows its blast wave through years, decades, centuries, or millennia. A galaxy can appear majestic while the medium shaping its light remains almost entirely abstract to you. Dust forces attention past the moment of impact into the material aftermath, into persistence, survivability, transport, coating, filtering, reprocessing. The result is not a less dramatic universe. It is a universe with more depth behind its drama. Depth is what keeps wonder from becoming shallow. And shallow wonder is easy to produce. It needs only scale and a raised voice. Deeper wonder is quieter. It takes work. It emerges when hidden complexity is made feelable without being falsified. Webb has made dust feelable in exactly that way. The evidence is real. The uncertainties remain where they should. And still the whole subject now carries a density of meaning that most people never associated with the word. Consider what has happened to our opening image. We began with dust in a beam of sunlight crossing a room. That image was useful because it captured the basic idea of the invisible becoming visible. But by now it is hopelessly inadequate. Dust in a room drifts through a relatively simple human environment. Interstellar dust does not merely drift. It participates in thermal regulation, chemical surface processes, radiation filtering, large-scale transport, and long generational transfer of material between stars and worlds. The domestic image collapses under the weight of what Webb has shown. What once looked like a minor analogy becomes a reminder of how badly earthbound intuition undersells cosmic reality. That is another pattern worth holding on to. The first analogy often fails in the end. It gets us started, then breaks, and the breaking is part of the education. We try weather, coastlines, frost, soot, tree rings, window tint, archives, scaffolding. Each captures something true and leaves something out. No single familiar object can hold all of dust's roles at once. That is not a failure of explanation so much as a sign that the subject really has crossed into a higher order of complexity. When reality starts outrunning any one analogy, you know you're no longer dealing with a simple category. Yet it is still possible to feel it. That matters enormously. Scientific literacy is often mistaken for memorizing terms or tolerating abstractions. But the more meaningful form of literacy is the ability to let reality change the shape of your intuitions. You do not need to retain every detail of PAH behavior, every uncertainty about grain size distribution, every nuance of attenuation curves in high redshift galaxies, to come away transformed by this story. What matters is that the old instinct has been corrected. Dust is no longer background clutter in the mind. It has become an active medium of consequence. And once that correction happens, one more emotional turn becomes possible. Gratitude. Not gratitude in the sentimental sense of thanking the universe for being beautiful. The universe is under no obligation to be beautiful or legible to us. A harder gratitude than that. Gratitude that conscious beings, after spending most of their existence under a sky they could only partly read, have learned to build instruments that can detect the thermal and chemical traces of tiny grains between stars. Gratitude that we live at a moment when the hidden support systems of cosmic history can be made visible at all. This kind of gratitude is closely related to humility. It does not inflate the human role. If anything, it diminishes our sensory authority. We are reminded that unaided perception was never enough, but it also honors what disciplined curiosity can do. A species that began by naming bright points and mythologizing patterns has reached the point where it can study the coated surfaces of microscopic grains in cold interstellar environments and infer something about the making of future worlds. That is an extraordinary extension of witness. Witness may be the best final human word for this. Not mastery, certainly not control, witness. We cannot touch these grains. We cannot stand inside those clouds. We cannot survive the radiation fields, the shocks, the cold, the distances, or the timescales involved. But we can witness, we can detect, compare, model, infer, revise, and slowly bring hidden structure into the circle of the known. Webb is one of the great instruments of witness, and interstellar dust is one of the realities it has helped us witness more honestly. That honesty is why the final perspective should widen now, not into vagueness, but into clarity. The universe is often presented as a collection of extraordinary objects set against emptiness. What Webb has shown, again and again, is that emptiness is often a failure of access. Between stars there are media. Inside media there are structures. Inside structures there are histories. Inside histories there are future conditions. Dust is one of the clearest demonstrations of that layered truth. It exists in the interval, but the interval is not null. It is active, burdened, consequential. In a sense, interstellar dust is where the universe keeps some of its hardest-earned continuity. Not in finished forms alone, but in carried material. Not in brightness alone, but in what brightness must pass through. Not in the loud event alone, but in the change conditions that remain after it. Not in the isolated object alone, but in the medium that joins one phase of reality to the next. And if that is true, then the ordinary meaning of the night sky has changed a little. Not because the stars are diminished, but because the darkness between them has become fuller. Fuller of matter, fuller of process, fuller of concealed preparation, fuller of records left by what has already happened and conditions gathering for what has not yet arrived. The sky is still full of lights. It is simply no longer only lights. And that is where the title finally becomes complete. James Webb revealed the true complexity of interstellar dust not because it found one shocking secret hidden inside a neglected subject, but because it made a whole chain of truths visible at once. Dust has structure. Dust has chemistry. Dust has multiple sources. Dust survives unevenly. Dust records pressure and timing. Dust alters the light by which galaxies are known. Dust appears early enough to challenge old assumptions about how quickly the universe became materially rich. Dust helps connect stellar death to future clouds, future disks, future worlds. The complexity is true because no simpler version can now hold everything the evidence has forced into view. But even that still sounds a little too clinical unless we let the emotional meaning settle. For most of human history, the medium between stars was not available to feeling. It was there, certainly, but there in the way deep ocean currents were there to a person standing on a beach before oceanography. Invisible, inferred only in pieces, too remote from the body to become intuitive. We saw stars. We saw darkness. We saw dark lanes in the Milky Way, and later learned those lanes were not merely gaps. But the actual fine-grained reality of what lay there, the cold coatings, the carbon-rich carriers, the layered remnants, the shell records, the drifting outflows, the early dust of young galaxies, remained outside ordinary perception. Now it does not. Not fully within reach, not reduced to simplicity, but within witness. That is a quiet revolution. It does not flatter us. It does not make the universe about us. What it does is let us stand, briefly and honestly, inside a larger truth than our senses were built to manage. It lets us see that what we call background is often carrying consequence, that what looks like residue can be infrastructure, that what seems to interfere with a view can also be the very thing through which the history of a system becomes legible. There is something deeply calming in that once the first astonishment passes, because it means reality is not thin. It is not just isolated bright events suspended in dead spacing. It is thick with intermediates, with transfers, with conditions accumulated over time. Dust is one of the places that thickness becomes visible. It tells us that the universe does not move from one dramatic episode to another through emptiness, but through media that preserve, alter, and prepare. Nothing about that is sentimental. It is simply more complete than the older picture. And completeness has its own form of beauty. A remnant is more beautiful when you understand that its layered dust is not just decoration, but the aftermath of pressure still written into matter. A cloud edge is more beautiful when the changing chemistry across it becomes visible as a kind of environmental geography. A shell around colliding stellar winds is more beautiful when it becomes a clock in drifting carbon-rich material. A distant galaxy is more beautiful when its dust is no longer a nuisance variable, but part of the evidence that the young universe was elaborating itself with startling speed. Beauty deepens when causality enters it. That may be the cleanest final lesson. Knowledge has not drained feeling from the cosmos. It has given feeling somewhere truer to stand. We do not need fantasy to make dust meaningful. We only need accuracy held long enough for its implications to become humanly real. Tiny grains, spread through darkness, changed by radiation, carrying ices, surviving shocks or failing under them, riding galactic winds, condensing in the ruins of stars, entering future systems. This is already enough to alter the way the universe feels. Not because it makes us central, but because it reveals how much was happening in regions we had once mentally emptied out. And perhaps that is the final reversal hidden in the whole subject. Dust was the thing we imagined as reducing clarity. Webb has shown that dust was also where clarity was waiting. Waiting in the sense that the evidence had always been there, written into emission, absorption, structure, and timing. Waiting for an instrument capable of reading it at the right wavelengths and with enough sensitivity to turn blur into terrain. Waiting for us to stop asking only what shines and start asking what carries. Waiting for the dark to be treated not as absence, but as a place where matter is still busy becoming. That phrase matters more than it seems. Matter is still busy becoming, not only in stars, not only in galaxies, in grains, in surfaces, in shells, in the slow cold chemistry that can unfold on an icy mantle, in the sorting of particle populations under harsh light, in the circulation of dusty material through a galaxy's larger weather, in the young universe learning, very quickly, how to complicate itself. Dust is one of the quiet forms that becoming takes, which means the night sky is a little less clean now than it used to be, and that is a gift. Cleaner is not truer. The stars still shine, but they no longer float in a mentally empty black. Between them is layered matter, damaged matter, surviving matter, transporting matter, cooling matter, recording matter. Between them is the medium through which one generation of cosmic structure leaves something for the next. That does not make us large. It does something better. It makes witness feel worthwhile. Because on one small planet, under one narrow band of visible light, a species of primates learned to suspect that darkness was not empty, then learned to build devices that could confirm the suspicion, refine it, and eventually make the hidden architecture visible enough to feel. We are small inside that fact, small in scale, small in duration, small in power, but not irrelevant. Consciousness became capable of tracing the route by which stellar remains become grains. Grains become chemistry. Chemistry helps shape clouds and disks, and later worlds emerge carrying the legacy of ancient stars. That is not a comforting story, it is a true one. And truth, when it is allowed to keep its full texture, can be more moving than comfort ever is. So the next time the word dust appears, it should no longer sound like a dismissal. It should sound like an archive, a bridge, a filter, a work surface, a shell, a record, a residue that refused to remain mere residue. It should sound like one of the universe's quieter ways of carrying memory forward. It should sound like matter in the long middle, between catastrophe and creation, between the visible and the hidden, between the lives of stars and the possibility of worlds. The ordinary word remains, the reality inside it does not. And somewhere between the stars, in regions so cold and dark and patient that no human body could ever follow them there, tiny grains continue to gather, glow, erode, survive, and drift through the enormous continuity of things, while, for the first time in the history of life on Earth, we have begun to see them clearly enough to understand that the darkness was never empty at all. And once that becomes real to you, even in a small way, a strange quiet enters the subject. Not because the science has become simple, it has not. Not because every frontier question has been resolved, It has not. The quiet comes from something else, from the feeling that a hidden layer of reality has stepped into view and, instead of making the universe feel chaotic, has made it feel more continuous, more inhabited by process, more faithful to itself. That is worth lingering with, because continuity is easy to talk about and hard to feel. We use phrases like stellar life cycle and galactic evolution as if they already carry their own emotional truth. Usually they do not. They sit in the mind as clean abstractions, but dust changes that. Dust gives continuity texture. It gives it surfaces, shells, coatings, dimming, glow, survival, loss. It turns the line between one phase and another into matter you can almost imagine touching, even though you never will. And that may be why this story stays with people long after the details begin to soften. You may forget the names of specific regions. You may lose track of which observation constrained icy grain sizes and which one traced carbon-rich features in a galactic wind. You may not retain every distinction between a harsh radiation field and a colder shielded environment, but something deeper remains. A correction in scale, a correction in respect, a correction in what you believe counts as central. The old instinct said, stars are the real story, and dust is what gets in the way. The truer instinct says, stars are still central, but the medium between them is carrying consequences you cannot understand the story without. That is a profound shift, and it is one that reaches all the way into the body, because the body is always trying to simplify distant reality into what it can emotionally hold. One bright source against black, one dramatic event against silence, one object at a time. Dust resists that compression. It asks the body to admit that the dark itself can be dense with preparation, that the interval can be active, that suspended matter can matter more than instinct permits. This is not easy knowledge. It is earned knowledge. Earned by building instruments that extend the senses beyond what evolution prepared them to do. Earned by learning to treat infrared light not as an exotic technical detail, but as a way of entering hidden temperature regimes and hidden structures. Earned by refusing to stop at the first answer, by refusing to let the word dust remain lazy. And what has come of that effort is not merely a better catalogue of material between stars. It is a more honest, emotional map of the cosmos. The night sky is still what it has always been to the human eye, darkness punctured by light. But behind that human view there is now another one layered over it, a deeper one, a sky crossed by dust lanes that are not simply shadows but concentrations, a sky where cold clouds hold icy grains and quiet chemistry, a sky where remnants preserve layered traces of stellar destruction, a sky where carbon-bearing material survives in some pockets and fails in others, a sky where galaxies vent dust-bearing matter into enormous outflows, a sky where the early universe was already accumulating texture while still young enough to seem, by older intuition, unfinished. That layered view does not replace wonder, it matures it. A mature wonder has a different rhythm from the kind we're usually offered. It is less interested in the one loud reveal than in the accumulation of connected truths. It does not ask to be stunned every minute. It asks to be carried steadily into a reality that becomes more coherent, more intricate, and more intimate the longer you stay with it. Dust is almost a perfect subject for that kind of wonder, because it rewards patience. It does not shout. It gathers force. Grain by grain, cloud by cloud, remnant by remnant, galaxy by galaxy. Until eventually the entire category breaks open, and you realize you are never looking at debris in the trivial sense. You are looking at one of the universe's great mediums of transfer. Transfer of elements, transfer of cooling potential, transfer of chemical opportunity, transfer of optical consequence, transfer of memory from one cosmic phase to another. And memory may be the last word worth holding. Not memory as intention, not memory as thought. Matter does not remember the way a mind remembers, but it remembers through condition, through what it carries, what it has survived, what has been done to it, what it can still do next. A dust grain altered by radiation is not the same as one protected in deeper cold. A shell moving outward from colliding stellar winds is not just matter in a pretty pattern. It is the preserved timing of repeated episodes. A dusty remnant is not merely what is left. It is the shape of a violent event still legible in cooling material. A young galaxy rich in dust is not only a surprise, It is a statement about how quickly prior generations of stars changed the material terms of the cosmos. Dust remembers enough for the universe to keep building from its own past. That may be the most beautiful sentence in this whole subject, precisely because it is not trying to be beautiful. It is just true. And truth of that kind carries an after effect. You begin to see how many familiar human habits it quietly undoes. The habit of privileging brightness over influence. The habit of dismissing what seems diffuse. The habit of assuming that the hidden is secondary. The habit of treating the space between important things as if it were merely delay or distance. Dust breaks each of those habits in turn. It tells us that hidden does not mean minor, that small does not mean weak, that distributed does not mean unimportant, that what lies between events may be what allows one event to become the next. This is why the story could never honestly end with a single headline claim. James Webb did not reveal one secret tucked inside interstellar dust like a note hidden in a wall. It revealed a whole new level of seriousness in the subject. It revealed that dust is not one problem but many processes, not one material but many populations, not one role but many crossings. It revealed that we had been using a humble word for a category that helps carry the universe forward. And perhaps that is the line that should remain when everything else is quieted down. The universe is carried forward by more than what shines. Stars matter, galaxies matter, gravity matters, but so do grains in darkness, so do cold surfaces, so do hidden layers, so do the materials that dim, glow, record, and prepare. Webb has let us feel that without exaggeration, and that is why the subject lingers. It enlarges reality without needing to mythologize it. In the end, the ordinary word dust survives, but it survives the way an old map name survives after the territory has been properly explored. The label remains familiar. The world underneath it has become immense. So now, when you look up on a clear night, you do not have to pretend you can see what Webb sees. You cannot. None of us can with our own eyes. But you can know that the darkness between the stars is not a blank holding pattern. It is full of work already underway, full of matter changed by old stars and waiting to alter what comes next, full of hidden chemistry and thermal glow and layered remains and future conditions gathering in places beyond the reach of the body. And there is something quietly overwhelming in that. Not overwhelming in the sense of panic, overwhelming in the way a deep truth can be when it finally finds the right form. The universe is not only made of objects, it is also made of intervals that are alive with process. Interstellar dust is one of the clearest signs of that. One of the clearest signs that reality does not reserve its deepest importance for what is brightest, loudest, or easiest to name. Sometimes it hides it in a word so ordinary you almost miss it. Dust. And now that word is no longer small,